All right, let's get started. Doing the vinegar milk of magnesia titration today. It's an acid-based titration. The idea behind a titration is that you take a solution whose concentration and composition you know, you use that to conduct a chemical reaction with a solution whose concentration you don't know, and then once you figure out, once the reaction takes place, you can go back and figure out what's in the unknown solution. So what we are using here today is a couple of things that are fairly common in terms of things you might have at home. In fact, other than the indicator, you could probably do this at home with stuff that you've already got. In terms of finding an indicator, maybe that's a different deal. But I'm going to start, just going to get a couple of eyedroppers, which you will use. The science term for this, these are called barrel pipettes, but they're eyedroppers. Okay? And what you're going to do is you're going to use a vinegar solution as your unknown. Okay? And so each group is going to need a test tube with some vinegar in it. And it doesn't take an awful lot, probably half a test tube or less. Okay? You won't even need that much. Okay? So we'll put that there, and in doing so, I'm going to take a marker. I'm going to label it so that I know what it is. So this, I'm just going to put a V. V is for vinegar. That's good enough for me. Okay. That's our unknown solution. Our known solution, and vinegar is an acid. Okay, we ought to establish that right away. Vinegar is an acid. Specifically, it is acetic acid, and you can find the formula for that. Our base is this stuff, milk of magnesia, magnesium hydroxide. Okay. Now, magnesium hydroxide, you have to shake up real well before you use it, because it will settle out if left alone for an extended period of time. And again, we don't need an awful lot of this. Just, that's probably too much, but we can work with it. Okay. Now, this stuff is fairly easy to tell what it is, but it's never a bad idea to label. I'm going to put an M on here. Okay. All right. Now, we're going to do 3 titration trials. Okay. So these other 3, I'm going to label 1, 2, and 3. Okay. The experimental procedure is fairly straightforward. We're going to take a known volume of vinegar, and that volume is going to be 30 drops. Okay. So what if you're putting it in and you overdo and you have 31 or you have 29? Not a big deal, but you do need to record what that number is. Okay. And because we're doing a number of drops, that's something that is easily counted. We're not going to worry about significant figures for that. Okay. Same thing with drops of the milk of magnesia. Okay. So we'll kind of go with that. So I have one of my droppers here, which I'm also going to label V. And I'm going to label one of my droppers M. And again, it's pretty obvious in this specific situation which one is which, but that might not always be the case. Okay, so you start with trial 1. Put it in here. I'm going to count out 30 drops. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 26, 27, 28, 29, 30. 30 drops, okay? 30 drops of vinegar, okay? And I'm gonna go ahead and I'm keeping my data on a little card. You have a little data table that you'll use. Just gonna write 30 drops of vinegar. Okay, now, when I add the milk of magnesia, you won't be able to tell that a reaction takes place unless you have an indicator. So I have this indicator, phenolphthalein. It's the one we used in the thing last week or last time. I'm just going to put 1 drop in. Now, when it comes to you, when you come up to get your supplies here, I'm actually going to put a couple of drops of this right into your vinegar, okay? That way you don't have to worry about adding it. It'll already be there. All right, so there's our vinegar, phenolphthalein. What will it look like when the reaction takes place? It'll turn pink, okay? So here's our milk of magnesia. How many drops is it going to take? Well, I don't know. Let's see. 1, 2, 3, 4, 5. Swirling it around, no pink color yet. Add a couple more. 6, 7, 8. Still nothing. 9, 10, 11. Oh, ooh, there's some pink. There's some pink. Okay, you see that? 11 drops. Okay, that's a good start. So for drops, milk, and magnesia, I'm going to record 11. We'll do the procedure 2 more times. Repeatability. And, you'll be able to calculate an average. Now, as you're using your droppers, it'll be a good thing to make them as close to vertical as possible, just because you want it to be the same every time. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. Okay, once again, 30 drops. Okay, and drop of the indicator. 1 is all you need. And again, I'll probably just put a couple of drops of this in your vinegar when you come up and get it. Okay, milk of magnesia. I'm going to do, okay, now see how I've smeared it across the side right there? I'm just going to leave that. I'm not going to count it unless it actually comes in contact with what's down here, because it's not actually reacting. Ideally, if you have better technique or better nerves than I do, you won't have that happen. But let's see, 1, 2, 3, 4, 5, 6, 7, 7 drops, 8, 9, 10. We have a little bit of pink at 10. Okay. That pink is a little paler than this pink, isn't it? Okay. Still pink though, which is good. All right. So 30 drops of vinegar, 10 drops of milk of magnesia. All right. So for our third unknown sample, once again, we'll get some vinegar in the tube here. Count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 9, 30. 30 drops of vinegar. And of course the indicator. What happens if you don't put the indicator in? It won't change color, and you can add milk and magnesia to it all day long. Never see a difference. Okay, so milk and magnesia. We'll start once again. 1, 2, 3, 4, 5. Nothing there. 6, 6, 7, 8, 9. We have some pink color at 9. Okay, so we're going to record 30 drops of vinegar, 9 drops of the milk magnesia. Okay, that's our data. What do we do with it at this point? Well, you know the equation, the acid-base titration equation. Volume of acid times concentration of acid equals volume of base times concentration of base, or MAVA equals MBVB. You have 3 of those values. You can rearrange to solve for the 4th. Calculate the concentration for each of these 3, average the results, and that's the number that you'll report as the concentration of the vinegar. Okay? There are some questions that will go along with that. To remind you of our conversation from the other day, the answers to those questions should be in your own words. Also, you need to show the calculations that you make in your data table, your data sheet that you got from Canvas. There's a couple of places where it says take a picture of your calculations and post them here. Please do that. I know some of you don't like to use paper in this kind of thing. I'm going to ask you to do it anyway. Okay? All right. Questions about anything? All right. I'm going to stop the video here. Well, let me say one other thing before you go. When you are done with the experiment, here's what you need to do to get rid of stuff. Okay? The milk of magnesia and the vinegar are both innocuous enough that we can just rinse them down the sink with plenty of water. The barrel pipettes or eyedroppers can just be placed in the garbage. The test tubes and test tube racks, let's put the test tubes, I think what I'm going to say is rinse the test tubes out as well, and then put the test tubes in the rack upside down so that they can dry. I'll lay out some paper towels over in that area as a place that we can set that up to do. Okay? Good enough. Distance learners, you've got the data now that you need just to take care of the calculations and stuff. Remember, this activity is the assessment for this week. This is the thing you get a grade for. Please do not neglect the pre-assessment that we talked about the other day. And that pretty well takes care of it. This is due Friday by midnight, please. Okay, that is all.